Alright guys, I'm having some technical issues, so I'd already made the video, but it messed up, so I'm starting back over, so part of it's already going to be written down, but we're going to be on page 42 of our journal, and we're going to be on the left side, and you're going to draw this picture. I'm going to put the original one. Now, if you are coming back to school soon, then you can get this picture when you come back. So what I want you to do is I want you to pause this video, and I want you to draw this on the left side of your journal, and I want you to push play after you've written it all down. I'm trying to make the video a little shorter so I don't have issues. Hopefully you paused the video and wrote this down, drew this, and we're going to talk a little bit about it. So, yesterday you were asked to watch 5 videos, and one of the videos had a little water diagram, a little water display, I guess is a better word. And what it did is it filled this one up with water, and this one was also filled up with water. And when she turned the little thing, these two filled up this C completely. And then once this C square was filled, she turned it again, and it showed that it filled up these 2 squares. Because when I take the side A and I square it, so 3 times 3, and I take the side B and I square it, it's going to equal this C. Alright, so we're going to go to the left side of the journal. Again, if you are coming back sometime soon, then you are more than welcome to just wait and get this when you come back. But if you're not coming back in the next day or 2, then I would recommend that you copy this down. Alright, so this is the foldable they're going to be doing in class. Kind of a little bit of a complicated foldable for what we normally do, but that's okay. And so we're going to start with our vocabulary. So we're going to title this page The Pythagorean Theorem. Hopefully you watched the videos yesterday, so you're not completely clueless. Pythagorean Theorem, sorry. And we're going to start with vocab. And I'm going to make a little vocab box. They have it as a tab, and that's okay. And we're going to draw a right triangle. Now, we don't want to make it too big because we do have 3 tabs. So there's my right triangle. And I'm going to label. I'm going to draw an arrow to this side and this side. And I'm going to say these are legs. Sides A and B. All right. Legs A and B. This third side here is called the hypotenuse. Hypotenuse. Not the easiest word to say. Hypotenuse. And this is side C. Our longest side across from the right angle. Hypotenuse. It is the side C, our longest side, and across from the right angle. Alright, then we're going to write that it is A squared plus B squared equals C squared. And we're going to put a little note. A squared means A times A, just in case we forget. Okay? Okay, our next tab is going to be examples, and we're going to look at a couple of examples. All right, so example 1 we want to find, I'm going to draw the triangle smaller so we can make sure to fit all of our examples that we're going to be doing today. So we have 5, 12, and then C. Okay? So to solve this one, we're going to first label our sides. So we have our C. It's across from our right angle. And then we have side A and side B. It doesn't matter which side is A and B. Doesn't matter. So I'm going to just do, A squared plus B squared equals C squared. Now plug that in. It's going to be 5 squared plus 12 squared equals C squared. So remember, A squared means A times A. So 5 squared, 5 times 5 is 25. Plus 12 squared, 12 times 12 is 144. So that's going to be 169 equals C squared. To get C by itself, we need to square root both sides and the square root of C squared. So C squared is C times C. So it's C. And 13 times 13. So that missing side is 13. Let's look at another example. Ooh, horrible right triangle. And this is 8, 8, and C. Our C is always across from our right angle. All right, so we're going to do A squared plus B squared equals C squared. It's always the same formula. All right, my A, I'm going to label, doesn't matter which one's A and B, so 8 squared plus 8 squared equals C squared. So 64 plus 64 equals C squared. So 128 equals C squared. So I'm going to do the square root of both sides. Well, 128 is not a perfect square. Now let's review ourselves on what a perfect square is. A perfect square is just like this picture. 9 is a perfect square because when I take 9 tiles, it can be made into a perfect square of a 3 by 3. 25 is a perfect square because it is a 5 by 5. And our 16 is a perfect square because 4 by 4. So it's not a perfect square. If I had 128 tiles, there's no way I could arrange those without cutting the tiles to make it. So we're just going to leave it as square root of 128, and that's okay. All right, let's look at example 3. This one's a little bit different. We're going to talk about that difference. We have 3, A, and 7. And my C is always across from that right angle, so that's C. That's A, so this has to be B. So, let's scoot this down a little bit. So I'm going to have A squared plus B squared equals C squared. My A, I don't know. There's no number with that A, so I'm going to keep it as A. My B squared is 3, so I'm going to do 3 squared. And my C was 7. So I'm going to do what I can. So I'm going to go ahead and solve those squares. So this is going to be 9. And 7 times 7 is 49. To get A by itself, I'm going to subtract 9 from both sides to give me that A squared equals 40. Then I'm going to do the square root of A squared. But again, 40 is not a perfect square. You need to do square root of 40. So A is going to equal the square root of 40. Now when you get into high school, actually next year in Algebra 1, you're going to learn how to simplify that a little bit more. In the video, they kind of showed you a little bit yesterday. Okay, let's look at one more example today, and then we're going to go and add a little bit to our other side over there. 25, B, and 7. So across from my right angle is always C. That's B, so that one's A. So we're going to have A squared plus B squared equals C squared. A was 7, so 7 squared. B, I don't know, so I'm going to leave as B. And C is going to be 25 squared. So 7 times 7 is 49 plus B squared. 25 times 25, I'm going to cheat and use a calculator, is 625. I want B by itself, so I'm going to subtract 49 from both sides. It's 576. So I'm going to do the square root of both sides. So B squared, square rooted, 576 square rooted. So B is going to equal whatever the square root of 576 is. Sorry, I'm using a calculator again. Square root of 576 equals 24. So that missing side is 24. Alright, let's go back to our left side because we're going to add a little bit to this. And we're going to do like a bubble. I'll finish the bubble in a little bit, but our first thing is Pythagorean theorem only works on right triangles. If you notice, every example we looked at was a right triangle. It has to be a right triangle. One of those angles has to be a right angle. It is used to solve a missing side. And I want you to box the word side, because some of you are going to try to use it to find missing angles. Side A and B don't matter. They don't matter. They can be switched. But side C is always longest. And across from the right angle. Oops, sorry, off the page. And I want you to bubble that whole thing, because those are the most important things about Pythagorean theorem that you need to remember. Alright, tomorrow we're going to practice some more Pythagorean theorem. We will continue working on it. You will have a homework assignment on it, and then next week you're going to have a test over. It'll be the first test of the next 6 weeks. If you have any questions, please send them my way. Good luck.